Hello everyone, I just want to do a quick video on a potential storm for the East Coast Sunday into Monday. And the trend right now has been more of a progressive system going out to sea, a weaker system. But there are a lot of things at play here. So let's first look at the 500 millibar vorticity map. This is today's run of the GFS. What you'll notice is you have a trough coming in from the northern part of the jet stream, and then you have other vorticity energy in the southern part of the jet stream. Notice that when I say energy, I'm talking about vorticity. I just say energy to make it easier to say. Vorticity is spin in the atmosphere, creates upward motion, and that leads to storms. So that's what we're looking at here with the trough coming from the north and then southern stream energy to the south. And what we want to see with this trough is we want to see it dig further south so that it goes negative, and then it allows the southern stream energy to move up the coast and get absorbed into the trough that's coming down from the north. And in the new run of the GFS that came in today, see the trough is neutral. It's not really negative. It's also very broad. It's not very well consolidated. So your southern stream energy is escaping out to sea, as you can clearly see. Here it is. It's not consolidating with the trough. It's out to sea. As compared to earlier today, and that what I just showed you, that's been the trend. But then what I saw earlier today on the GFS was here's your southern stream energy. Here's your trough coming down. It's digging more to the south. And then look at this. It's more consolidated, darker reds, more vorticity. It's stronger. It's going neutrally tilted a little earlier, and then it starts to go negative, and bam, here it is. Look, the southern stream energy is closer to the coast now, and it's going to meld, or at least get close enough to the coast that it can create somewhat of a storm and produce some snow. Now, nothing does show this energy really consolidate. I mean, it does a little bit here, but nothing shows, and look again, the trough is negative. So nothing shows that this is really going to be a strong storm, but I still think there's a possibility to get some snow out of this, and there's a reason for that. So first off, this is the only GFS run I saw that has that solution. And you know, sometimes it's helpful to look at the ensemble models when you're farther out in the future, like 5+ days. The deterministic models don't always have a lot of reliability when you're further out into the future. So this here, the ensembles, it's a suite of GFS, like different types of GFS models with different initial conditions in the atmosphere, and they produce a suite of solutions. I think there's 20 or 30 members. So this is like an ensemble mean from all the ensembles that we're looking at here, and just showing you the location of the low without going back to the GFS. This is about the same location that the GFS has, except that it's weaker with the storm. And just to show you this morning, so you could see that this is the surface map that's in the same location, but it's a stronger storm, as you know, was evidenced by the vorticity map. But it's in the same location, which is good. But the ensembles are weaker with it. But to be honest with you, I mean, yes, we would get a much stronger storm. Excuse me, a lot more snow if the storm was a lot stronger. But I still think even without a strong storm, you can still get a decent amount of snow out of this. Now, when I say decent amount of snow, I mean several inches. I don't mean a foot or 2 feet or anything. Not like the last storm. But the thing to really keep in mind here is, before I get to relative humidity, I want to take a look at this. Okay, this is temperature at 850 millibars. This is all cold air to the north, and then you have a boundary draped here. If you see wind shifts, that's how you know there's a front. So if you look here, you look at the wind barbs, they're going from southwest to west to northwest. So you have a boundary in here with this area of low pressure as this moves east, and it's draping back into the Midwest, and this is Friday evening. So watch what happens as it moves to the east. The cold air comes pooling down into the northeast and the mid-Atlantic states for the weekend. You have this high here, this 1034 high. that's going to be funneling this cold air down into the northeastern states. So the cold air is there for a storm. And whenever you have boundaries like that, that boundaries tend to be breeding grounds for coastal storms to form. The boundary is probably somewhere off the coast now. The storm can form out ahead of or along the boundary and ride that boundary up the coast depending on how the trough is oriented. That's one thing. The second thing about having a strong boundary like this is that you get a lot of moisture advection. A lot of moisture develops because you have a temperature gradient, what we call a baroclinic zone, and so you get a lot of moisture developing as a result of the front and the storm forming. So that brings me to the next map I want to show, which is relative humidity. And so the green areas represent higher regions of relative humidity and more moisture. So even though the storm is off the coast here, late Saturday night, look at all this higher relative humidity values across the East Coast. So, and as you go forward, that storm comes up and it intensifies, and the relative humidity is still pretty strong going into Sunday evening. As the storm moves away from the coast, it pulls away, and keep in mind this is the 18Z GFS, so this is the one where the storm's going out to sea, not the other one. I could show the other one. In fact, why don't I do that? Look at this. This is Sunday evening. This is the stronger solution that I was showing you, and the storm is stronger, and it's at 998. But look at that. Look at all this relative humidity coming on the backside. So what I'm saying is, look at that plume of moisture there. So what I'm sorry to be so repetitive. I didn't prepare well for this, but what I'm saying is that even if we have a weaker storm, I still think there's going to be a lot of moisture associated with it. So on the western end, that precipitation shield is going to come back pretty far. Even if the storm tracks out to sea, I think you still get some snow out of this. I don't think it'll be a lot, but I think it's good enough that you get something out of it. So I did want to show the surface map. So this is the surface map for the stronger model solution. So this is Saturday evening. There's your storm forming off the coast of Georgia, and then it's bringing snow into the Virginia. It's actually going pretty far inland in this stronger solution, and then it comes up the coast. It's not tracking inside the benchmark, the 40-70 benchmark, but it is close enough that the precipitation shield is coming all the way back further to the west, further inland. New York City, Philly, and DC are all included in this now if this is the solution that happens. And then Boston, of course, too, and coastal Maine would be in it as well. Now, if we go to the 18Z solution, which is the more common solution among the models, you see that there is now a weaker storm much further east, and that we get brushed by light snow, and that tends to be it. So what would need to happen for this to develop into a stronger storm, for that earlier solution of the GFS to be correct? Well, first off, let's go back. I think this trough needs to be more consolidated and stronger like it is in the other solution. I think this southern stream energy needs to be a little quicker so it gets out ahead. And I think what needs to happen is this needs to dig further so that it can go negative and absorb, or at least consolidate somewhat with that southern stream energy and bring it closer to the coast so that we get a storm. Now, nothing is showing that right now. The only thing that is that earlier run of the GFS that's showing that. Do I think it could happen? Of course. We've seen this pattern many times before, where the solution is always further east to begin with, and then it comes back further west. The thing that worries me is that the cold air is coming in pretty early. So the front is going to be well out to sea, and while the low doesn't necessarily have to ride along the front, it usually does ride along the gradient of warm and cold air. And so I tend to think that if this trough doesn't set up the way it should, where it goes negative and digs further, then I think there's a higher chance the storm goes out to sea. due to the fact that the cold air is coming in uh, during the day on Saturday as opposed to, even 24 hours later. Um, so that's my only concern about this coming further west. So can it come further west? Yes, I think it can. Will it? I'm not sure. I'm 50-50 on it, so I'm not even comfortable issuing a threat area right now. Um, I may not even do a video tomorrow. I may wait till Friday, but let's see what happens and let's just keep an eye on it. And if something develops, I will be back. All right, thank you for watching, everyone. Talk soon.